Let me just continue from where I stopped last time. So I was trying to explain this particular line to you. This first one, they didn't talk about. They talked about it can be arranged anyhow. Talking about the arrangement could be anyhow, and they didn't even tell us if there's going to be replacement or not. So we assume that there's going to be a replacement. Now, that is why we use the full sample space. For the first one, I talked about the figure from 0 to 9. That's the first one. The second one, talking about the 26 alphabet. Third one, fourth one. And that's why we have 26, 26, 26, 10. Now, for this other one, the difference is that they told us that there won't be replacement. And there won't be replacement. So, if there won't be replacement, this is what will happen. The first one, which has a letter of 0 to 9, that's 10, to be intact. The second one, which is alphabet 26, the first one with 26, and the next one, since there's no replacement, it means that it will reduce by 1, that'll be 25. And the following one, the last space too, will reduce by 1, so that'll be 24. That's the meaning of replacement. It will be reducing 1, 1, 1, 1 as you move. For example, if this 10 is supposed to repeat itself here, it will not be 10 again, it will be 9. But because you're just in the space once, that's why it is this. So the difference is that this one, let me read it again. Okay. Now note that if repetition of a letter are not allowed, and this is when the condition, when there is repetition of numbers are not allowed, that's when we have this. If repetition is allowed, that's when we have this. So when you multiply 3, you have this. So please just understand the logic. Now, this last example, each time a coin is tossed, there are two possibilities. Possible outcome. Either it land up or it land tail. Sorry, whether it's land head up or it's land tail up. You toss a coin, either you have head or you have tail. Now, using the fact that the multiplication principle, you can conclude that if a coin is tossed 8 times, there are going to be when it comes. So if you are throwing it once, if you throw it once, you're going to have 2 space, head or tail, right? So that's why we have 2. So say it's tossed 8 times, so we're going to have a figure for each space. So 1, 2, 3, 4, 5, 6, 7, 8. Those are the number of times that's been thrown. Now we are going to have 2, whether it's head or the tail. So that's 2 possibilities for everything. Same thing, that's the same multiplication principle we are talking about. So I'll give you this. So that's that about that. If I want to use this example, if let's say it is tossed twice and they told us that there's not replacement and like there's no repetition, that means you're going to add the first one to be 2, second one to be 1. But that's not the case here. So that brings me to this next topic, permutation and factorials. Now suppose we want to determine the numbers of different ways. 3 letters A, B, C can be placed in order from first to third. The following is the list of all possible orders in which the letter can be placed. You can have it ABC, ACB, BAC, BCA, CAB, CBA. Now, there are 6 possible orders for the 3 letters. It can be arranged in 6 different ways. So now suppose we want to determine the number of different ways of 4 letters A, B, C, D from 1 to 4. We are going to follow the same approach too. But however, okay, the other two, okay, okay, so order for 4 letters, one of the 4 letters must be placed first, then one of the remaining 3 letters must be placed second, one of the remaining 2 letters must be placed third. Now, what they are trying to do is this. Even for these 3 arrangements, you have 3 letters, If you have 3 factorial, which is 3 times 2 times 1, that's 6. So the same thing goes here. Since you are telling you to arrange 4 letters, how many ways can you arrange 4 letters? That is, the meaning of that is 4 factorial, which is 4 times 3 times 2 times 1. It goes on like that. This is different from multiplication principle. Don't get it wrong. This is just number of arrangement of a number. Talking about arrangement here. So for example, these 3 number alphabets can be arranged. If it's 3, so that's 3 factorial, that would be 3 times 2 times 1. That gives you 6. That's why they go 6 here. Instead of you writing out this, which might consume your time. So for 4 letters, for you to arrange 4 letters, the different possible outcome that you can have is 4 times 3 times 2 times 1. This is different from multiplication principle. This one is talking about permutation and factorization. Now, use the formula n into n minus 1, n minus 2, n minus 3 like that, but you don't need to do that. Just make sure it's going down. So talking about the permutation now. So this is example of factorial. 1 factorial means 1, 2 factorial means 2 times 1, 3 factorial means 3 times 1. So even if it's 10, that will be 10 times 9 till you get to 1. You multiply it downward like that. So 4 factorial means 4 times 3 times 2 times 1. So that gives you this. So that's the meaning of factorial. So you get to what you multiply it from the number downward, and you are reducing one number from the preceding one. For example, this 4, then 3, then 2, then 1. You multiply it through. So and this is the general formula. We don't need to crowd them, I just add that logic. So if it's 10 factorial now, see, suppose that 10 students are going on a bus trip, each of the students will be assigned to one of the 10 available seats. Then the numbers of possible different seats arrangement of students on the buses. So talking about arrangement, when you're talking about arrangement, that's what we're talking about. Talking about factorial. So since they're talking about 10 space for 10 students, that will be arranged. So this is 10. So 10 times 9 times 8 times 7 times 3 times 5 times 4 times 3 times 2 times 1. So that will give you this. So even if it's 100, same thing. Talking about it, when you're talking about arrangement, that's when you use this. Please try to understand this. I know this kind of topic can be so can be difficult for some people because it requires you just thinking about in a particular way. Now that brings us to permutation. Right? Permutation. Now what you need to do when you're talking about permutation. We have permutation, we have combination. When we're talking about permutation, we're talking about arrangement, orderly arrangement of something. When you have permutation means that when you are picking a particular number from a general number. You understand? And this is a formula. But let me just talk about it. More generally, suppose that k objects will be selected from a set of n objects. So that means this is the total number, and you want to pick just how to select this k subject from this n objects. So where n is more than k. In this case, you're talking about that k is smaller than n. So that means you're going to pick a particular number. So from n, so how can you arrange? That's when we have two values now. Talking about how a particular value can be picked from the other. Then we have permutation and combination. And the difference between permutation and combination is when we are talking about permutation, we are talking about arrangement in orderly manner. Combination is talking about when it is arranged anyhow. There's no order. So now here's the formula. All you need to know for this permutation is just this formula. N factorial. And I told you, the meaning of factorial. Factorial means that you multiply from that particular number downward till you have 1 over n minus k. This k is the number that you are going to be selecting from n factorial. So that's this formula. You just need to know it. So for permutation arrangement, write it down in your notes. This is the formula. Let's apply the formula. How many different 5-digit positive integer can be formed using the digits 1, 2, 3, 4, 5, 6, 7? Now you see that we're talking about how many 5 digits can be formed from this 7-digit number. So this is 1 to 7. So that means in this arrangement, your n will be what? Your n will be 7 because you have 7-digit number that you pick from. Then your k, which is supposed to be smaller than your n, will be 5. So let's use the formula. For example, so this your n will be 7. So this n will be 7 factorial here, and 7 minus 5 factorial. So that's the formula. So that's what they did here. Over 7 minus 5 factorial. So when you do that, you have 2 factorial down here. Then 7 factorial will be 7 times 6 times 5 times 4 times 3 times 2 times 1. But they were very smart here. 2 factorial is the same as 2 times 1. You get? But because they want to cancel this one, since they multiply, so they just left it at 2 factorial. So 2 factorial will cancel 2 factorial. So even if it's 3 factorial that is down here, so you stop at 3 factorial here. So you cancel each other. So you just have 7 times 6 times 5 times 4. Even if, so, but in this case we have 2 factorial. So they stop at 2 factorial. They divided this, they have this number. So that's permutation. That's how to use the formula. But I want you to try it yourself, and let's see how far you can go. For combination, it's the same principle as permutation. The only difference is that when you're talking about permutation, I told you that they're going to be order. Okay, now look at it according to the counting principle above. Let me see. Look at how permutation quotient looks like. How many different 5-digit positive integer can be formed using the digits 1 to 7 if none of the digits can occur more than once in the integer? So this kind of orderliness, there's this kind of condition that will be attached to permutation. But for combination, it's free. You can say the arrangement can be anyhow. It doesn't have to be order. You understand? So combination is not talking about, it's just like arrangement anyhow. There's no orderly in it, and that's just the difference. Now, this is the formula. Let me just skip through all this. It's not necessary. You just need to know the formula. Still using the, compared to what we were talking about, if you are supposed to pick a combination of k from n objects, so you just have n factorial k factorial into n minus k factorial. That's the formula. So if you use this rightly, you're going to get your answer. So now this is a combination question. Look at it. Suppose you want to select 3-person committee from a group of 9 students. How many ways are there to do this? Now, here did not tell you if it is chosen once or if it is ordered. It's obvious that the arrangement can be anyhow. Look at it. Since the 3 students on the committee are not ordered, you can use the formula for combination of 9 objects taking 3 at a time. Now, according to this question, group of 9 people, so n will be 9, k will be 3. So when you use that, so that will be n factorial will be 9 factorial, k here is 3 factorial into 9 minus 3 factorial. Then we do it. You have 9 factorial, 3 factorial, 9 minus 3 is 6, so that will be 6 factorial. So when you do that, 9 times 8 times 7. You understand factorial? Look at what they told you. So this 6 factorial times 6 factorial was supposed to be like 6 factorial. So because 6 factorial will cancel 6 factorial, so that's good. So that's what they did. They did show it. So 9 times 8 times 7 times 6 factorial, they stop. 6 factorial will cancel 6 factorial down here. So this 3 factorial will be 3 times 2 times 1. That's 4. So that's the difference between permutation and combination. So just know the formula. Use the formula for combination, and that's the formula for permutation. And permutation is used for talking about orderly arrangement, and combination is talking about arrangement but that is not ordered. So that is all I want to talk about right now. Just know the formula when you have any issues. Then another thing you must know is that 0 factorial is 1. Yes, 0 factorial is 1. So you can see 0 factorial is 1. So please, when you have 0 factorial, that will be 1. So that's the formula. So I'm talking about probability.